Tires are often called the soul of movement because they are the only part of a vehicle that actually touches the road. Every year, the world produces around 2.5 billion tires, more than 7 times the population of the United States. Yet, few people ever stop to think about how a tire is made. From the milky white latex dripping from rubber trees in tropical plantations to the incredible grip that holds a Formula One car steady during a high-speed turn, each tire is the result of a sophisticated engineering process. Built from dozens of layers bonded together, a tire must withstand heat, pressure, and friction over hundreds of thousands of kilometers. Whether you're driving a 600-horsepower supercar or a family sedan without good tires, all that power means nothing. In this exploration, we'll go inside the fascinating process that transforms raw materials into one of the toughest, most reliable products in the automotive industry. A tire might look like a simple ring of rubber, but it controls everything about how a car performs, how well it corners, how quickly it brakes, and how stable it feels on different surfaces. Behind this seemingly simple piece of rubber lies a global industry operating in over 180 countries, with thousands of factories producing enough to meet the demands of nearly 1.5 billion vehicles on the road. The tire industry is worth an estimated $320 billion, fueling constant demand for natural rubber, steel, and synthetic materials. In Formula One racing, a single set of tires might last just 50 to 100 kilometers, sometimes barely surviving one lap. The quality of a tire can mean the difference between victory and disaster, between smooth acceleration and a dangerous skid. Beyond racing, old tires find new life in playgrounds, furniture, and soundproofing materials, proving their story doesn't end once the ride is over. Before a single tire is produced, engineers spend countless hours designing and testing it digitally. Tire design involves determining the ideal cross-sectional shape, ply structure, tread pattern, and rubber composition to balance grip, durability, load capacity, and noise reduction. Every type of tire, whether for high-performance sports cars, heavy-duty trucks, or everyday passenger vehicles, has a unique blueprint. Advanced simulations test these digital models for aerodynamics, stress distribution, and wear patterns before moving on to physical prototypes. The journey of a tire begins in tropical plantations where natural rubber is harvested. Workers use sharp knives to make precise cuts into the bark of rubber trees, allowing latex, a milky white sap, to drip into small collection cups. These cuts must be made with surgical precision. Too shallow and the latex won't flow, too deep and the tree could be permanently damaged. The collected latex is preserved with ammonia, then transported to processing facilities where it's concentrated, rolled into thin sheets, and dried. However, natural rubber alone isn't enough to meet the demands of modern driving. It is blended with synthetic rubber, an artificial material developed through petrochemical processes that use molecules like butadiene and styrene. Synthetic rubber is stronger, more consistent, and performs better under extreme temperatures, making up about 60% of the material in a modern tire. Once the rubber materials are ready, they undergo the material mixing stage. Contrary to popular belief, rubber isn't naturally black. It's the addition of carbon black tiny particles that reinforce the rubber and increase durability that gives tires their familiar color. In large industrial mixers, natural and synthetic rubbers are blended with carbon black, softening oils, sulfur, and dozens of chemical additives. Each ingredient has a purpose. Carbon black enhances strength, softening oils maintain flexibility, and sulfur helps in the vulcanization process that hardens the rubber. These ingredients are mixed at high temperatures and pressures until they form a dense jet black compound. Flattened into thick sheets and cooled, this rubber compound becomes the foundation of every tire's strength and flexibility. The next stage is building the tire's structural components. Sheets of rubber are rolled out and combined with high-strength synthetic fabrics and ultrafine steel wires to create layers that form the tire's internal skeleton. A process called calendering coats fabric with molten rubber under precise temperature and pressure, ensuring tight bonding between the layers. The steel wires, aligned perfectly in parallel, are embedded into the rubber to form steel belts that help the tire maintain its shape at high speeds. These reinforcements give the tire its resilience, helping it resist deformation, absorb shocks, and maintain stability across diverse driving conditions. Once all components are ready, the assembly process begins. Using a large rotating drum, robotic systems precisely apply layer after layer of rubber, fabric, and steel. Every movement is monitored by sensors and cameras to ensure flawless alignment. Even a fraction of a millimeter's deviation can compromise safety. The layers are pressed together tightly, and the raw, unvulcanized tire, called a green tire, is inflated with compressed air to take on its rounded shape. This marks the transition from raw materials to a unified structure, though it's still soft and unfinished. The next critical phase is vulcanization, where the green tire becomes a fully functional, durable product. The tire is placed inside a heavy steel mold, which is heated to around 160–180 degrees C. Inside the mold, a flexible bladder inflates the tire with compressed air, pressing it against the mold's intricate patterns that form the tread design. During this process, sulfur in the rubber reacts chemically with polymer chains, creating crosslinks that transform the rubber from soft and sticky to tough, elastic, and heat-resistant. Vulcanization typically lasts between 10 and 15 minutes, and it defines the tire's final performance characteristics: its strength, flexibility, grip, and lifespan. After vulcanization, the tire goes through a rigorous quality control process. Industrial laser scanners measure every dimension, roundness, thickness, and alignment to ensure absolute precision. The tire is inflated and spun at high speeds to test its structural integrity and air retention. In advanced factories, X-ray imaging reveals hidden defects such as misaligned layers or weak bonding points. Only tires that pass every test receive the manufacturer's approval mark and are sent for distribution. Once on the market, tires face a long and challenging life. After tens of thousands of kilometers of friction, heat, and stress, they eventually wear out. Each year, billions of discarded tires accumulate worldwide. Unfortunately, tires are not biodegradable. Left to decay, they can release harmful chemicals, microplastics, and even toxic gases if burned improperly. To combat this environmental issue, recycling technology has become an essential part of the tire industry's future. Old tires are shredded into small granules and treated through chemical and thermal processes to restore some of their original properties. This recycled rubber is often reused in the inner layers of new tires or in other industries such as construction, playground surfacing, and sound insulation. Though recycled material currently makes up only 10–20% of a new tire, it represents an important step towards sustainability and circular manufacturing. In conclusion, beneath what seems like a simple black circle lies a masterpiece of science, engineering, and precision. A tire may appear modest, but it is the only point of contact between a multi-ton vehicle and the road, where performance, safety, and control all converge. Every detail, from the molecular structure of the rubber to the microscopic grooves in the tread, is carefully engineered to deliver reliability and confidence in every drive. The next time you see a tire rolling down the road, remember the incredible journey it has taken, from the quiet rhythm of latex dripping from a tree to the roaring power of a racing circuit. It's a story of innovation, resilience, and the pursuit of perfection in motion. If you found this exploration insightful, consider leaving a comment, liking the video, and sharing it with anyone curious about how the world works behind the scenes. And don't forget to subscribe to the channel for more deep dives into the extraordinary technologies that shape our everyday lives.